Okay, so now we're live on YouTube for this final presentation of today's Prairies Day in the Regional Week presented by VECA. So of course, thanks VECA and our gold sponsor to Everlast. So today for this last presentation, we have another quite big panel. So right away, Al, I'll pass it to you so you can introduce us to all these people.
Yes, our guests on the panel today are Dave Goldsmith of Plygem and Cornerstone Brands. We have Randy Krebs of the Alberta Association of Architects. And we have Peter Schultz, an architect from Calgary, I believe. Is that correct, Peter?
Correct, yes.
Who's also on our panel with us today. Our topic, we're going to ask Dave right now to maybe tell us what was the genesis for the topic that we're going to discuss today. And then Dave will take us to the next segment.
Sure. So Plygem Canada, manufacturing out of Calgary, we serve the Western Canadian market, which is BC, Alberta, Saskatchewan, and Manitoba. And we're seeing really mixed practices in the markets that we serve regarding the requirement for professional design and field review on non-exempt buildings, which most of us think of as being non-Part 9 buildings, but it's a little bit more complicated than that. So we'll refer to them as non-exempt buildings. They're buildings that are not exempt from professional involvement like Part 9 buildings are. And so in certain markets, like the lower mainland of BC, the island and the Okanagan, we're seeing practices that are really consistent. And I think due to the leaky condo issue they had years ago and the involvement of insurance agencies, they're making sure that all of the I's and T's are dotted and the professional involvement is done to the maximum extent. In other municipalities, it seems like the requirements are unclear in the minds of many, which creates concerns at the quoting stage, because the professional involvement will come after the quoting stage. So you need to be quoting accurately at that stage, taking into account whether or not there's going to be professional involvement in order to be quoting the right products. And if you don't do that, then once the contracts have been awarded, if there's any expensive change orders, well, the budget has been set, the loan has been made, and that's all the money there is, and there ain't no more. And so if there's expensive additional requirements, that somebody's going to have to eat that, and it's going to come out of their profit margin and make the difference between making a profit or losing money on a project, sometimes for the window fabricator and sometimes for the contractor. So that's a concern. But what really is the central concern, I think, is if there is no professional involvement, that opens everybody to liability. Because when the building envelope scientists, they have professional liability insurance. The engineers that are operating in the field that Al will describe to us, doing the jobs that Al's going to describe, they carry professional liability insurance. So the building owner and all who are involved in this process are covered should there be an issue with the windows. And if there's no professional involvement, then you're opening yourself up to liability. And in that world that we have out there, that almost anybody can sue almost anybody for almost anything. And the first thing somebody who's looking to sue someone does is they try to demonstrate that, these guys were a bunch of clowns. They didn't know what they were doing. They weren't following the proper procedures. I've been out to that building. They don't even have safety glass in the windows that are required by code to have safety glass. So what's the electrical like on this building? What the other things, the foundation, that type of thing. So really, you need to have the proper professional involvement in order to be doing right by your customers and by the building owner. And so we've been dealing with this for many years, and at one point I reached out to the Association of Professional Engineers and Geoscientists of Alberta, and they said, well, this is interesting, but really this falls under the architectural discipline. They're the ones who are accountable for everything that falls under that discipline, including everything that has to do with the exterior facade of the building, its structural attributes, its safety attributes, and its water resistance attributes. And that got the ball rolling, talking to Randy Krebs of AAA. And we identified a need for some education out there in our industry to try and get us on the same page, be reading off the same page. And of course, who should deliver that educational content? Well, we have a very good national organization that is an expert at presenting content relating to fenestration, and that's Fenestration Canada, and Al Yogelis, Technical Director of Fenestration Canada. So that's how we came to be here today. And now I'm going to sit back and enjoy the presentation, and then we'll have some time for question and answers at the end.
So thank you very much, Dave. Just to let folks know, towards the conclusion of my presentation, I'll introduce Randy Krebs, who will, share his thoughts on the subject, and then we'll move on to back to Dave for a panel discussion. So. If you can let me share my screen, Steph.
You should be okay now.
Good. All good?
Yep.
Yeah, we can see.
Great. So, this presentation is adapted from a longer presentation I have about the NAV standard and the code, and specifically focusing on why NAFS testing alone does not satisfy code requirements for windows in non-exempt buildings. A couple of introductory comments just to set the stage. The code assumes that testing to NAFS and the Canadian supplement to NAFS is sufficient to qualify the Part 5 structural, air leakage, and water penetration requirements for fenestration. But if we take a closer look at what the NAV standard says about its testing, we realize that this is not the case, because NAVS testing doesn't actually test the structural attachment of the windows to the walls. It doesn't test the air or water tightness of the window to wall interface. And it doesn't qualify the glass strength of the products either. And the fourth item is just the practical reality that it's not possible for manufacturers to pre-test all the possible options of their product lines. So they cannot qualify the complete range of sizes and configurations that architects and customers expect. Now, in some jurisdictions, architects are required to ensure that registered professionals are involved in the preparation of design and to ensure that the work of the contractor is reviewed for alignment with the design through in-shop or on-site field reviews. So the involvement of registered professionals to design and review can address the things that NAFS testing leaves out. The structural design and review of anchoring of the fenestration products to the walls, design and review of the window to wall interface to limit air and water leakage, the structural design and review of framing members for all window configurations to resist project wind and guard loads, and structural design and review of glass to resist structural wind and guard loads. So in this session, we'll review the Part 5 structural air water requirements of the 2019 Alberta Building Code, which are the same as the 2015 National Code. We'll review the limitations of lab testing with reference to the 2011 edition of the North American Fenestration Standard. And we'll identify areas where professional design and field review are required for windows and doors and skylights in non-exempt buildings. Basically to address the gaps between what the standard covers and what the code assumes the standard covers. And finally, we'll discuss current challenges faced by industry with respect to the need for professional design and field review. That's a topic that Dave will pick up on after Randy speaks. So the topics we're going to cover here, and this is not a long presentation, but it's going to set the stage for our subsequent discussions. First of all, why is the NAV standard in the code? Is NAVS testing sufficient to address Part 5 requirements? We're going to look at the actual language there. And ask the question, is professional design and field review necessary for windows and doors in non-exempt buildings. So why is NAFS in the code? Basically, NAFS appears in Part 5 of the code in subsection 592, titled Windows, Doors, and Skylights. And the way this is written, it takes you from general statements to applicable standards, and people tend to stop right there at the applicable standards and miss the whole point of this section and subsection. So I find it helpful to obscure that for the moment and get right down to why is the NAV standard in the code, or another way to rephrase it, what is the main thing Part 5 is concerned about when it comes to windows, doors, and skylights? And we find that right here in Article 5923, which is titled Structural and Environmental Loads, Air Leakage, and Water Penetration. Structural, air, water. These are the three properties the National Code says are the Part 5 properties for windows, doors, and skylights. And it tells us how they shall be designed and constructed. They shall be designed and constructed in accordance with Article 5141, which deals with structural and environmental loads. They shall be designed and constructed in accordance with Section 5.4, which deals with air leakage. And they shall be designed and constructed with Section 5.6, which deals with precipitation and preventing precipitation from damaging the building integrity or affecting the use or occupancy of the building. And then we have a or. Or, instead of, designing for structural environmental loads, instead of managing these three items from the Part 5 point of view, Article 5922, where they are covered in the scope of the standards listed in sentence 59221. Now we come to Article 5922, applicable standards. And this article is telling us that windows shall conform to the requirements in NAFS or the Canadian supplement to NAFS. And then it talks about performance grades being selected and so on. I think it's very important to read this Article 5922 with reference to Article 5923. And what this is telling us is the code seems to think that if products are conforming to the NAFS and the Canadian supplement, they have satisfied the requirements of design and construction to Article 5141, Section 5.4, and Section 5.6. The code leads us to believe that, and I suspect the code writers sincerely may have thought that. But I would say that we need to have a look at the NAV standard and to check that out. So Part 5 makes it clear that the code believes testing to NAFS in the Canadian supplement is one way of qualifying windows, doors, and skylights for structural air-water performance. These standards also qualify secondary attributes such as ease of operation and durability, but those are not the concern of the code. The performance class attribute is really important in the NAV standard for classifying products, and it's useful to the specifier, but again, it's of no relevance to the code. The code just cares about those structural air-water properties. So let's have a look at NAFS testing, and does it address these Part 5 requirements? Here's what NAFS says about test specimen installation. These tests are used primarily to evaluate the performance of the fenestration product and are not intended to test the performance of the installation, particularly the perimeter sealants between the fixture and the test specimen and the anchoring of the test specimen, test assembly to the test fixture. So this is not the intended purpose of the standard. The standard is intended to qualify the product and not how it's integrated into the building. And that continues to say testing of actual field installation Oh, sorry, this is my words, not the standards words. So yes, the testing of actual field installations is not required under NAFS and is not ordinarily performed by manufacturers. So we're going to identify here 4 important limitations of NAFS testing. For one, it excludes testing of the anchoring method from its scope. Somebody has to deal with that. NAFS recognizes that it's not practical for manufacturers to test every possible anchoring method in every possible substrate. There are wood walls, steel stud walls, concrete, unit masonry. You know, each substrate, each wall condition might require different anchoring methods. And even if the methods are similar, you're going to have to require different fasteners given the different, you know, shear and pullout properties of fasteners in these different materials. Secondly, NAFS permits test specimens to be anchored in ways that result in the highest possible structural ratings. And the anchoring of test specimens often differs from real-world anchoring methods. Basically, the standard, because it excludes the anchoring method as what is being tested, manufacturers are incentivized, you know, manufacturers want to get the highest rating for their product because they're competing against company B, C, and D. And the reality is when you see, you know, if you had the opportunity to witness NAFS tests in a lab, you will typically find the products anchored in ways that are not the same anchoring methods you would use in a typical building configuration. So it means that because NAFS specifically excludes the testing of any particular anchoring method, it means that it must be designed and reviewed by a registered structural engineer to address the building substrates of the building in question in a way that accommodates expected building movements and deformations. Another limitation is that NAFS does not test real-world window-to-wall interfaces. These diagrams are from the standard, and they show you the way the standard wants you to integrate or how to mount the window product into a test fixture. And it essentially requires there to be a face seal between the fenestration product and the test buck. And it requires that the interior side of the fenestration product be left open for examination to see if water is leaking between the joints of the product. That's the intent of the standard. So it's not testing your typical, you know, weather barrier, or shall we call it, you know, the continuity of air barriers and water barriers in the wall to the fenestration product in a real world situation is not the purpose of the test. Now, granted, it is possible to conduct a NAFS test with a real world installation method, and that would be a valid thing to do. But some of the real world anchoring methods require a drained sill pan under the window and other sealants and materials that would actually obscure what's going on with the window frame and make it difficult to tell if the window product is leaking through its own joints or not. And so while it's possible to test real world installations with the NAF standard, it's not the intent of the standard. And so you can't assume that any given product has been tested with a real world window to wall installation method. So the NAFS test does not normally qualify any given window to wall interface. Another limitation is that it's not practical for manufacturers to pre-test all the possible configurations of their product lines. Every window schedule will contain untested configurations and sizes. It's just a fact of life. And that means that project-specific engineering or post-award testing is required to qualify the untested sizes and untested configurations. If we look at an example of what a typical manufacturer would be expected to have in the way of NAFS test reports for, let's say, a particular casement awning window product line, you would expect to see individual units tested at the largest size the manufacturer would want to sell, or to get the highest possible performance rating. So these sizes are probably designed at the gateway size or larger to get the maximum rating. And then they also will test the largest practical sizes to pre-test in the lab to qualify, you know, the largest number of options that they might encounter. So, you know, testing a large size like this will qualify anything smaller at the same rating. Same for this kind of event or these options here. Here you're looking at possibly an integral mullion between an operable sash and a fixed window. And here you are actually testing field mulled joints or frame to frame mullion joints, which is a different kind of mullion condition. So, you know, the manufacturer will likely have at least this much testing and maybe a couple of other extra options. Maybe there are some other mullion or coupling options available. But this is the kind of thing you've got in sort of on file in your system. And then you look at a typical project window schedule and you don't know what you're going to get, but you might end up with something like this, where even though the manufacturer has tested a very large window, something over 7 feet tall in this case, which is, you know, massive in terms of a casement window, but it still falls short of the size of the project window and has significantly different configuration. These horizontal joints, as well as these vertical joints, you know, you cannot say that the condition on the left qualifies the condition on the right. So the reality is that because of the impossibility of qualifying all these project conditions, there is a need for project-specific engineering review of the mullions and even of the various joint interfaces. For example, those horizontal mullions that we see here, if these are field mulled joints, then, you know, I suppose you could say they're qualified by this field mulled joint, but you still have a different loading pattern on these mullions than was tested here. You've got various loads from this, you know, point loads on the mullion. So that's the reality. And finally, the fourth limitation is that the NAFS testing does not qualify the glass strength. NAFS 11 clause 10.2.2 requires glass to be designed to resist wind loads at project sizes using the glass design standards referenced in the applicable code. So that in the case of Canada, that would be, you know, CGSB 1220, and the code now also allows ASTME 1300. But the standard is clear that the lab testing does not in any way validate the specific glass makeup used in the test. So the tested glass is not in any way representative of what should be installed in an installed window on any given project. A National Building Code or Alberta Building Code Article 41516, loads acting on guards, specifies additional loads that windows often encounter, which is that the glass and or the frames of windows must resist guard loads when they are below the applicable guard height. And practically speaking, in the industry, glass strength is qualified on the basis of engineering calculations, not on the basis of physical testing. That means that the project glass must be designed and reviewed by a registered structural engineer to address all the applicable loads and conditions. So NBC Article 31118 requires guards to be present where there is a height difference of 600 millimeters or more from a walking surface to an adjacent surface. And that means that walls are also expected to act as guards. In fact, NBC Article 41516, loads on guards, walls acting as guards, specifies the specific loads that walls must be designed to ensure that they can function as guards. When windows are integrated into those walls, then windows also are subject to this requirement. And when window sills fall below the guard height of 1070 millimeters, windows too are then required to act or to resist the same loads as the wall would acting on a guard. So the glass or a horizontal mullion must be designed to resist the same guard load as the wall. If there is no mullion at the guard height, the glass needs to do the job. Alternatively, a mullion could be introduced at the guard height, but you'd want to make sure that the load there would be transferred to the wall, and you would also want the guard load to be added to the glass wind load for a proper calculation of the glass strength, because the code requires you to add up all the possible loads that could act on that glass. Alternatively, you can avoid this problem by installing a separate standalone physical guard in front of the window, which is not something people usually want to do. Now, the same requirement applies to windows in a stairwell, except that for stairs in dwelling units, the guard height is reduced to 900 millimeters, according to NBC sentences provided here. So we clearly see that even if you could qualify the glass design of a window through NAFS alone, you would still be faced with guard requirements, which affect a surprising number of windows. So to answer the question, is professional design and field review necessary to qualify the design and installation of windows in non-exempt buildings? We have to say, yes, it has to be necessary, because NAFS testing doesn't test the anchoring method. It doesn't test any particular window to wall interface. It does not generally enough test data available to qualify all the possible window sizes on any given building. And it does not explicitly qualify the glass strength for wind and guard loads. So at this point, I'd like to introduce Randy Krebs, an architect and the Director of Practice with the Alberta Association of Architects, because there's he's been involved in the development of this presentation, and Randy is aware of the content that I've presented here, and he's asked us to let him say a few words here at this point of the presentation.
Yeah, that's great. Thanks very much, Al and Dave, first of all, for inviting me and giving the opportunity to just supplement this presentation. It's very informative. There's a lot that I learned even being part of this process. So the level of technical expertise that Fenestration Canada has is very impressive, and we're very pleased to be delivering this content in partnership with you. So we just wanted to really add on to what has been said already, and just give the participants in this presentation just a few reminders from the perspective of the regulator's perspective. So just a quick summary. The Alberta Association of Architects is the regulation body. So we handle all the registration, licensing of members and firms in the province that practice both architecture as well as licensed interior design. But for the purpose of this presentation, since we're dealing with building envelopes, we are just limiting our discussion to the architectural components, of which LIDs are excluded from providing service. So from our perspective, really, there was the discussion on the non-exempt buildings. And the way that the Architects Act is written and the Safety Codes Act, which enables the Alberta Building Code, basically what happens is any building, if you're talking about a residential building, let's say of 5 dwelling units or more, requires professional involvement throughout. So it's roughly equivalent to what Dave had mentioned, the Part 9 versus Part 3 distinctions, but there is some minor differences there. And just to note, that includes secondary suites as well. So from our perspective, what our interest is as the design regulator, we're not necessarily here to advocate on behalf of the businesses of our members. What our mandate is really to remind the public that we are there to protect the public interest. So we are concerned when we see things that happened or happen where professionals should be involved in the work, and they're excluded from that involvement, either because maybe somebody's trying to take a shortcut, or they're just not aware that there's that requirement in law. So any opportunity we have to just sort of remind people as part of this type of presentation certainly helps out. So the two key components to window design that Al mentioned that we find particularly important are the design of the building envelope, the aspects related to weather protection. And we've seen some confusion in the industry with regards to who has that responsibility. From our perspective, it's very clear in our Act and clearly defined in the definitions sections of the code that anything that relates to building envelopes, an architect must be involved. Now, that's not to say that there's a lot of times where we work with our structural engineering partners to do a variety of pressure testing or leakage testing, and even provide a lot of input into other aspects of the design. But ultimately, that responsibility, overall for the building, and in particular the building envelope, lies with the architect. So that's one important point to raise. The point about smaller projects or exempted building projects is worth highlighting as well. There is a portion of the code that actually allows a code authority to require professional involvement on the entire building or portions thereof, even if it is exempted at the higher level. So that's sort of something to be aware of. So as you're proceeding with your projects, you might want to get in touch with your authorities early on, or if you ever want to contact the association, that's part of our role, is to respond to public inquiries. We can point you in the right direction in terms of what's expected by the legislation. And our website is listed up there on the screen at aaa.ab.ca. So yeah, and when it comes to the structural aspects related to anchorage and lateral loading design, again, the code is very clear that is something that requires the input of a structural engineer, and those individuals are frequently part of our project design team. And when we talk about professional involvement, it means professional involvement through all stages of the design and construction, start to finish. So even if we have, let's say, an engineer that's working for a window supplier and providing certificates that the design is compliant, there's an expectation that the coordinating professional record, who's usually the architect, gather all those certificates, make sure the appropriate field reviews are conducted and shop drawings are prepared. And that's really an underlying role and responsibility of the architectural professional record. So yeah, just wanted to emphasize, like, we're not there to be acting as police officers here. We really see the involvement of design professionals as something that adds value to projects. We've seen all too frequently where things have not included professionals and then tended to go off the rails. And in the long run, it results in extra costs. So, and you run the risk of having a project that doesn't comply with the legislation. So just to reemphasize, like, our mandate is to protect the public interest, not necessarily the business interests of our members. There's other organizations who have that type of mandate. So just once again, you know, an offer that if there's ever any questions, please reach out to us. We've got a series of practice bulletins that are available online at the AAA site. Practice Bulletin 26 that's noted here in particular describes exactly what those limits are between exempted and non-exempt buildings. There's some diagrams in there that help people figure out exactly when professional design is required. And we're here to support you. So please reach out at any time. And thanks again for the invitation.
Thank you very much, Randy. Really appreciate your your participation to clarify these matters. So at this point, I think I would like to turn it over to Dave and to tell us about some of the things that he's encountered in this area.
Got to unmute there for a second. Yeah, so let's talk about Alberta specifically. So, you know, we made a corporate decision some years ago to, you know, to the maximum extent possible, make sure that we're operating in a way and we're making others aware of the correct ways of doing things. And if someone is intentionally not doing it the correct way, we would just walk away from that. We don't want to be any part of that. That having been said, and there are many channels of sales available for larger companies. There's dealer sales. You can buy hundreds and hundreds of windows through a dealer, and they're not going to ask what the project is and where these windows are going. They're just going to sell you, you know, what you wanted, and we have no way of knowing. What we're seeing generally is we sometimes come across architects who believe that the code sections that you showed, Al, that all they need to do is have the NAFS test report to be compliant. And then we have to go ahead, Al.
Oh, and I must say that if you read the code without intimately knowing the NAF standard, you would logically conclude that, right? Because the code says you design for these conditions or you test to these standards. So the code, you know, encourages a, you know, basically the code just doesn't know something, right? And what we've tried to show in this presentation is that the NAF standard itself excludes itself from critical areas, you know, that we've identified. So this is something that, you know, I say I wouldn't fault, you know, architects for not knowing this, because the code, in a sense, you could say, has misled them to think that this is covered. So, you know, this is a kind of a public education effort here, just to inform people that the NAF standard scope is more limited than the code seems to believe it is. And that's what leads to the need for this discussion.
So what happens is window fabricators wind up being in the position of trying to push this, where it really should be getting pulled from the top end. And that can put everybody in a very difficult position. You know, at the end of the day, the architect, the building envelope engineer, they're the ones who get to decide whose product to use, right? So you cannot really fight with them and get down to brass tacks in that way. All you can do is, you know, recommend that, you know, there's now going to be some educational resources regarding this, and we're going to have some ongoing sessions potentially directed specifically at architects. This is just the first session, and this session will of course be posted online. It's going live right now on YouTube. And there are people who sincerely believe for factory manufactured windows that it's all down to the manufacturer. So we have had building envelope engineers, we had some unfortunate wording that was our boilerplate wording on our shop drawings that we've gotten rid of. It was a little bit too firm. It said something to the effect that if the windows are not installed properly, then your warranty is not applicable. That's not the case. That's not our policy, but that was some boilerplate language that was on our shop drawings. And we had a building envelope engineer come back to us, and he made the following request of our shop drawings. Please show membrane installation at the rough opening on all sides, membrane tie-in with the field membrane, second line of defense against water entry, including back dam at sill, air barrier continuity, flashing on the exterior, drainage of incidental water below window, etc. Thanks. So I am an engineer, but I am not trained in building science. I'm not qualified to practice in that field. We do not offer professional services, supporting registered professional services, and we do not have professional liability insurance, neither in the building envelope or in the structural aspects that Al is describing. And if we were, nobody offers those services as a fabricator, because you can't be both the fabricator and the person policing the fabricator. You know, that would be a conflict of interest. So, but we do have some heavy pressure sometimes to try and perform those roles. And then we have to push back and say that's not appropriate.
Yeah, I would say that's the key, right? I think you're identifying an issue that occurs sometimes. I mean, there's a lot of professionals that understand what their role is, but at times, you know, for reasons that Al has pointed out, you know, there's things that might lead them to believe one thing over another. What I can say is that the whole notion of good practice in building envelope design has been identified as an issue by the AAA in recent years. In fact, just over the last couple of years, the association has created a new course for its members. So it's an online course, takes place over, you know, a series of several presentations. And it's something mandatory for all our members. What I have seen in the industry is, you know, there's just a broad range of practices and involvement in different building types. So, you know, certain architects may have different levels of exposure, but that idea of if you find yourself in a difficult situation and it seems like you're being put in a position where you're expected to comment on things that are, you know, beyond your area of expertise, I think that's a good red flag to say, hey, you know, we gotta make sure that the right people are involved. And like I said, if there's ever any questions, that's what we're here for, to help the broader industry out, just to sort of sort through those problems.
And so I think at this point, I'd like to open it up to questions. Or Peter, do you have anything that you would like to say on these topics? You're muted.
I enjoyed the presentation very much. I have nothing to add. I think that was very good. And in regards to the code section, it's, I mean, yeah, maybe the code section needs to move to the upper part of the page, and the other things need to move down to bring it into the focus, I think. Mm-hmm. Sometimes you find those things that are, yeah, as Al had alluded to, you know, you read through and then you stop. Yeah, that's not good.
It shows you how one word can make a huge difference, right? Yeah. Like if that was or was an and, it would be completely different.
Do we have any online questions yet, Stefan?
Yes, we do. So let me start my camera here. So we have one question here. Can operable windows, casement, and sliders be used where the guard load rule applies? This is referring to Al's explanation on guard loads on wall and windows integrated as part of it.
Actually, Dave, do you want to handle that one?
Yeah. Well, it gets a little muddy because when there's a window in a stairwell, it says it needs to be non-operable and designed to withstand the loads for balcony guards. There's no direct code reference regarding the requirements for windows and walls that are required to act as guards, except that in structural commentaries, it makes it clear that they need to be able to resist both guard loads and wind loads. Now, professionals operating in the field will exempt lights that are lower than a certain size because the intent is for nobody to be able to fall through the window, right? So if the light's so small that it's hard to imagine somebody going through, then they might say, well, we're exempting this from needing to be tempered to meet guard loads. And you, I suppose, could make the same argument on an operating unit if it was small enough nobody could conceivably fall out of it. But then somebody might refer to the other part of the codes that makes it clear that windows in stairwells have to be non-operable and designed to meet the specified lateral loads for balcony guards. And now you're in a battle that you're not going to win.
And this, so this is this is, I think, an example of, well-intentioned code requirements that overlap in awkward ways, where what do you do now? Does that mean, I think the safest answer would be then let's design the casement window with a horizontal mullion at guard height, and therefore the casement operator above the guard height is now not subject to that guard load, and the horizontal mullion could be taking the guard load for the window. Now, architecturally, this may be something the architect doesn't want to see, but now you've got a problem. You've got a window somebody could potentially fall out of in a condition where the code is saying they're not supposed to fall out of it. There should be a guard there. So what do? Do you install a guard in front of that operable sash? So I think this requires now some creative architectural thinking, is maybe we need a different operating mode window here. Maybe it should be a hopper or an awning underneath the guard height or above it or something else. But essentially the operable window with below the guard height is now really not a viable option. Because of the requirements.
So here's what we're finding designers are doing for these windows that are affected by this. They will tend to design it, it's a large unit, they'll make it a multi-light unit. It'll have a horizontal mullion at the guard height. The lights below the mullion will be tempered, and the light above, the largest area of glass above, will not be tempered. And the lights below, if they're smaller than a certain area, they won't need to be tempered according to the rule of thumbs of professionals operating. Furthermore, if they are large enough that they need to resist guard loads, when you have a horizontal mullion, the guard load is 1,000 kilonewtons on the mullion and only 500 kilonewtons over a 100 by 1 or 200 by 200, no, I think it's 100 by 100 square area on the glass. It's only 500 kilonewtons when you have that horizontal mullion, but it's 1,000 kilonewtons when there's no mullion, when it's just direct to the glass, according to chord language. So you can wind up, if it's a very large light, it can wind up being 4 or 5 millimeter glass tempered. And in the second case, the largest light of glass is not required to be tempered at all. And the small lights may or may not even require tempering. But if they do require tempering, they might meet guard load at 3 millimeters or 4 millimeters, because it's only 500 kilonewtons guard load for the infill panel. And it's 1,000 kilonewtons for the main resisting part.
Now, and it's interesting, when you're talking about tempering the glass below the railing, I guess the assumption is that you're treating that horizontal mullion as a guard. Yes. And designing the glass for glass infill in a guard. But the actual code language does not say that the window shall function as a guard. So the code just says, like the wall is supposed to take a guard load, and the window is supposed to take a guard load. So I believe some engineers are just taking it, applying the guard load to the glass of the window, for example, or the guard load to the horizontal mullion, but the code does not say that that window has to be a guard. It just has to resist the guard load.
Well, you're very right, Al. The code language is fuzzy in some areas, and it's subject to interpretation by engineers, and they have their rules of thumb.
And this is where their professional judgment and liability concerns come in, right? This is a case that does not have a black and white answer. Is that right, Randy?
That's what I was just going to say. I mean, there's sort of an overarching principle that sits over everything, and that's good design and engineering practice. So this example just demonstrates how many different interrelated factors there could be in the design of a particular element. And I think it, further enforces why, making sure those professionals that are required to be on the job are indeed doing their work. And you might actually have a situation where one architect or engineer interprets those circumstances slightly differently. But the key point is that liability and interpretation now lies with those design professionals. And that should be something owners and operators of buildings are looking to transfer those risks to those professionals. If there's a situation that occurs where those professionals should have been involved and they weren't, something bad happens, then yeah, places people involved in a pretty bad situation. So yeah, that's a great example.
Okay.
Yeah, and I think one of the reasons it's like this for factory manufactured windows is on the main building plans, you have the names of all the registered professionals that are part of the general services package, typically the contractor, the architect, the structural engineer, the building envelope consultant. So those are all paid for by the building owner, and they're seen right up front at the beginning of the project before any windows have been quoted. But due to standard industry practices, when professional involvement is required for the windows, those tend to be rolled into the window supply and install contract and negotiated between the window fabricator and the contractor. So it's being pushed from the bottom up rather than pulled by the top down. And so I'm not in any way saying that architects are being non-professional. We've kind of, by the code language and by the standard practices, we've set them up for failure to create a gray area here, right? So the desired effect is to educate them and to have them demand it and pull the requirement through the system rather than us trying to push it.
And one way of doing that is just to standardize architectural specifications, just to make this clear. It is the practice in in British Columbia, and I believe it comes from the Architectural Institute of BC as the driver for this, is that all fenestration specs have language that the fenestration supplier shall engage a registered professional engineer to design the framing, the glass, the anchoring, etc., to the requirements of the code. And that responsibility now is very clearly in the spec. That means that the fenestration supplier has to carry that cost. It means all the fenestration suppliers bidding at the job have carried that cost. It means you can hire any of them and know that this will be covered and it will not fall through the cracks. So, this is something that, could be, I'm not sure which association might take that up in Alberta, but that is one way of managing this kind of risk, is to just ensure that it's embedded routinely in project specifications. And then it's clear to all parties in the whole supply chain that this is just how it's going to be.
Yeah. And I think we've got the opportunity to assist with that.
Okay.
That's sort of a separate exercise that is spun off from this presentation. So, sure. So we're actually in the process of creating a section on our website that deals with good practice standards and references, and that type of sample specification, if you will, could certainly form part of that resource library. I think that would be a really good idea. And because it's got a related component there with structural engineers, we'd certainly want to communicate with our partners at APEGA. But they've been really great to work with. We've got a good relationship with the professional engineers, and it's really at this point, like you said, all about just reaching out and being as informative as possible to the industry.
So I know with regards to APEGA and Engineers and Geoscientists of BC, they have practice guidelines that indicate very clearly that if the engineer is doing the design review and signing and sealing the shop drawings, that same engineer must be the one who's doing the field review. They can't delegate. Well, they can delegate it to somebody who works for them who's under their direct supervision, right. But they can't delegate that back to the architect, for example, right? And so I think the message for architects is if you're not aware of these requirements and someone makes you aware of them and you don't enforce them, then be aware that you're on the hook for the professional design and review. of the fenestration, even though you know nothing about it, and the window fan manufacturer knows everything about it.
Yeah.
You know,
Not
and they will want to put that on the
everything.
manufacturer, right?
Yeah, the core concept is whether you're an architect or an engineer, whatever you've designed, you've got a responsibility to make sure that the design has actually been implemented correctly in the
Yeah.
field. It's no use
Yeah, and-
preparing a design that gets built some different way, right? It's sort of like the missing piece of the puzzle.
So you know what larger companies do. I'm not exactly sure how many do this. What at the point of quotation, they will do an informal review that mirrors what the third party professional review will cover. For instance, PlyJam, we have automated mullion validation within our outer entry software that tells you the DP that the mulls meet. And then we would also analyze the glass strength for wind loading and which windows would require to meet guard loads and whether the glass meets guard loads. And we're not doing this to fulfill the professional obligations. We're doing this so that we don't get a shop drawing back that's covered with red ink that says you need to increase this glass thickness from 3 millimeters to 4 millimeters and make it tempered and increase the reinforcing of the mullions. And you know who's going to have to give that away? It'll be the fabricator who has to give that.
Actually, you raise a good point in the fact that the code refers to a field review, but in the portions of the design that you just referenced, I believe it would be entirely appropriate if that type of review was a review of what happened in the shop, in the fabrication shop.
Mm-hmm.
Like you're not necessarily concerned, and you're not necessarily signing off on how it's installed within that opening and connected, but the aspects that you're testing for and observing for are would be entirely appropriately done in the fabrication shop. So that qualifies as that field review. That just shows you how intricate and related some of these components may be. We see it in other aspects of building design where a number of different engineers are involved, let's say in foundation systems or sprinkler systems, and at the end of the project, that coordinating professional of record has to understand that anybody that's contributed to that design has to be able to stand behind that and verify that what's been constructed ultimately in the field is matches that design and meets the code requirements. So that's just an underlying obligation that can sort of help guide the whole process.
Yeah, and I don't think the requirement for professional design and review totally lets the fabricator off the hook. It doesn't. We know the market that we're selling into. We need to be sure that we're selling products that are suitable to that market and encourage the professional design and field review, which covers you from liability.
Yeah, I'm thinking if I were somebody supplying that type of product, I'd be very interested in how those products were being installed. If I went out in the field and saw it in a horizontal application all of a sudden or something like that, and like, what? Hold on, that's not how this product was ever intended to be used. So, I know people try to, draw those lines very carefully and add all the disclaimer clauses, but that sort of highlights what the underlying role of design professional is. It's really about public interest and the public mandate first, and then even to the point where that may have an impact on the personal business interests. That's what it means to be a professional.
Awesome. We have a couple more questions here.
If I could just make one
Yep.
point related to what was just discussed, we a few minutes ago we mentioned the presence of internal reinforcing might be required for that horizontal mullion. Very often, especially in a non-metal window system, whether it's fiberglass or vinyl, you often will need steel reinforcement within the vertical mullions, quite commonly. And again, that's something that's done in the shop and is not easy to verify in the field. I know some engineers do it. They bring magnets just to see if there's something magnetic in the frame, but that doesn't tell you whether the pieces of steel in the frame are continuous or segmented. And I know of a case where, you know, there was an investigation of a window failure issue, and there was definitely steel in the window frame. It had the right profile and cross section. Unfortunately, it was put in there in pieces and not as a continuous length. And of course, it had an entirely different outcome in the real world. And this is where, you know, in some cases, I know in many cases, say an engineer working regularly with a fabricator, they know they will trust them to do these things. But you know, you can't just assume that just because something was on the shop drawing, it's actually present in the product. And there is this obligation to actually try to, you know, do your best to verify that you know, at some level you've actually inspected that, you know, continuous pieces are going in there and they're fastened, you know, according to the schedule that you specified. When that condition later becomes enclosed and impossible to verify. So,
and here's something you didn't mention in your presentation, Al, is that under NAFS, Class R and Class LC products have no deflection limit at the specified design pressure. But in Part 4, there's a limit of L over 175 for all of the cladding components and glass supporting components. And under the Canadian glass standard and the American glass standard, they both assume that the glass is rigidly supported at the edges enough that it's not going to deflect more than L over 175 at the design pressure. So that's a big hole in NAVs. That came from the American Architectural Manufacturers Association. They wanted to differentiate residential products from commercial products. So they had no deflection limit on residential and light commercial, and a deflection limit on commercial windows and architectural, as a kind of a marketing scheme of the standard. And now we're kind of living with that in Canada. And so this can result in some really weird things happening on Part 9 buildings. And on your presentation, Al, there was, I think, the video of a certain incident that occurred on a Part 9 building, if you want to bring that up, and I will describe it.
oh, okay, yeah. And actually, we should amend this presentation to address that Class R and LC condition.
Yeah.
So yes, let's see. Okay, I've got that slide here. Let me share my screen.
Well, while you're doing that, Al, I see a question about architects assisting GCs with the understanding about who is performing the professional review. I'll just add in a couple of quick comments.
Sure, by all means.
So for non-exempt buildings, there in Alberta, similar to BC, we've got the whole, we call it here the Schedules of Professional Involvement program. And that those certificates are submitted at the beginning of design. They're co-signed by the owner. They identify all of the design professionals that are expected to be involved in the project. And what those schedules say is that those consultants will continue to be involved in the field reviews through the course of the construction. And that process is completed with a schedule that gets submitted at the end, certifying that those field review services were indeed provided. So a good architect should be able to advise their builders and their owners about that process that exists in the code. And again, if there's any questions, give us a call.
So just to discuss in advance what Al is going to show, if he can get it up. But so we had a project in Calgary where it was a Part 9 building, and the homeowner was being their own general contractor. And they went to get the absolute least expensive windows that they could for this project. And they went to a company that was set up probably 6 months earlier, that was basing all of their NAVS results on fabricators' test reports. And like many manufacturers starting out in the early 90s, needed to go through the school of hard knocks regarding vinyl windows and mullions. They hadn't been through this school yet. And so they mulled very large units with very long mull spans and absolutely no reinforcing in the mulls. And these windows basically were falling apart on the job site. The corner welds were cracking due to excessive deflection of the glass and excessive deflection of the mullions. And so our salesman went out and basically pushed on the window, and that was where this amusing video was showing him pushing on this window, and it's bouncing like a limp piece of spaghetti and not supporting the glass at all. So I've never heard of that occurring on a non-exempt building, but it is in the range of possibilities. And there it is right there. I don't know if you can play that, Al. There we go. Those mullions are longer than any that we would make, even with our heaviest reinforcing. And it's just creates a product that's tremendously flexible. On the left, you see a picture over slider. That's wider than any slider that we make. It's like about as wide as a patio door and has an unreinforced mullion going all the way across. And the Home Depot people in Kamloops basically said, Plygem really needs to step up their NAFs, because here's these windows, they're larger than anything Plygem makes, and they got a PG 50. How can you explain why you suck and these guys don't? And I said, next time you're out on the job site, give a little push on the mullions with your pinky finger. And then think of what's going to happen when a serious windstorm comes up at that site, and whether the glass is going to be subject to breakage for excessive deflection. So these are possibilities out there. If you're dealing with companies that don't know what they're doing and are not following the correct process, you can get yourself into real trouble. Thanks, Al.
Yeah, you're welcome.
Yeah, it's almost like there's separate mini industries within the overall industry. And sometimes you get builders, consultants, owners transferring from one building type to another. That's where some difficulties can occur.
Okay. Let's go to another question. Someone's asking, what sections of the building code relate to NAFS testing as requirement for doors?
I can handle this, Al, if you like.
Sure.
So it used to be the NAFS didn't apply to swing doors or slide doors. There was a different standard. But when NAFS came along, it started to apply to swing doors and slide doors. So they fall into the same system and they have to meet the same requirements. That having been said, there's not a lot of field water testing of the swing doors, because it is difficult to get the lab tested values. With a lot of swing doors. I mean, the panels are a commodity item. There are thousands of panels to choose from, thousands of door lights to choose from. The panels may have embossing that will interfere with the seal, and they may have a surface roughness on the edge that will interfere with the seal. So in order to guarantee that your swing door is going to pass a field water test, you would really need to sand the edges of the panel, make sure the door was perfectly adjusted, and lock properly with a multi-point lock and adjustable hinges. And so what we find is that they tend not to test the swing doors. They tend to be under large overhangs anyways, and there's no history of failure leading to building envelope damage for swing doors. So they tend to ignore those in the swing door water testing. When the day comes when they stop ignoring those, and this is starting to happen with some contractors in BC, then that's going to be trouble for the typical pre-hanger, because you would need like a different type of product, like a European style vinyl frame, reinforced, seals like a casement door, to guarantee that you're going to get window-like performance.
Okay.
Interestingly enough, when we first educated manufacturers about the NAV standard in BC, a number of them went and actually developed products that could achieve these water penetration resistance ratings. But typically most of them who succeeded, the ones who succeeded, mostly relied on, especially for in-swing doors. Out-swing doors, easier challenge. In-swing doors, the hard one. They actually developed different door sills that were more amenable and different weather strips. So it is possible. And some of them actually introduced multi-point locking, because one of the problems is, especially when you build a taller door, these insulated doors structurally are not very stiff. And sometimes they just didn't have enough compression on the gaskets at the top without a multi-point lock. These additions, added hundreds of dollars to the cost of a door. And so they were competitively, shall we say, value engineered out of most construction projects. but they do exist. There are manufacturers in Canada who have actually designed doors with tested NAFS ratings that are good enough to actually withstand a field water test. But they're in a small minority, and it looks like the majority of the pre-hanging market is just carrying on as usual. And it's up to, I guess, buyer beware. If you're not having risks and not having problems, but technically the code is clear that such doors do not comply with the code.
Yeah.
If they do not
So-
comply with the standard. So the reality is that there's probably fairly significant level of non-compliance depending on region with respect to this issue,
So we thought we were in that minority that was fully compliant, and we found that there were some difficulties. I mean, you've got these embossed panels. They have these heavy wood embossing. It goes all the way to the edges. Sometimes they have decorative details like grooves that go all the way to the edges. The customer expects to order any panel out of any vendor's catalog, and there are 3 or 4 vendors, and put it in your door frame and have it pass with flying colors. And we just find that that's going to be a hit and miss on the doors.
That's true. I mean, the reality is once you're testing a product for a performance level, you can't substitute components. Like you're basically talking about component substitution. And in the pre-hanging door market, it's typically like a job or assembly thing. We can get you any door panel, any hinge, any this, any that. We'll build it for you. In that model, you can't guarantee the performance of anything. When you're trying to build a product that has tested air and water ratings and structural ratings, you're now limited in the components you can use that actually, that all components, because you're testing a system, you're not testing a door panel. And the system is the interaction of all the components. And so you can't just willy-nilly swap things like door panels because of unintended consequence. All of a sudden, the gasket doesn't prevent the leakage through the groove door or the embossed door. So the whole business model of pre-hanging, it's like the indoor pre-hang market, right? Well, we've been doing exterior doors like we do interior doors. We'll build you anything you want.
Yeah.
When it comes to once you start having to tighten up that building enclosure, you can't really have the same business model for doors successfully. So this is a challenge. I mean, there's economics involved here and all kinds of other things, but clearly you have to manage the components. You will have a limited number of options in a door that's qualified properly to NAFS, a much more limited number of options than you could use if you were not constrained by testing to that standard.
Okay.
Terry Adamson made the comment, BC has several good performance NAVS rated swing doors, but as mentioned, site testing is challenging with install challenges, etc.
It's true. It is challenging. Yes. And you're more likely to succeed with a more European type design door than you are with a typical North American door. I was just thinking we haven't given a chance for Peter Schultz to get into this conversation, and I don't want to leave you out, Peter. I'm wondering if you have any thoughts or comments to share with what we've been going on about here.
No, I think that was all good information, so I don't have anything to add, I would say.
Okay.
So we do have a question here that we didn't answer yet, so I can read that. How do the sealants fit into the acceptance of the product and installation? Who does the checking? This is a question from Gordon.
Well, for the installation, that would be the building envelope engineer, I would think.
I would, if we're talking about a non-exempt building, then we're talking about a building with professional design and field review, where you would think there's an enclosure consultant probably helping the architect, or maybe the architect is acting as the enclosure specialist, but presumably whoever that professional is should be qualifying the materials and the methods used at some level. Is that correct, Randy?
Yeah, back to the slide I presented. Building envelope is architect. And I know that you frequently have an envelope engineer showing up hopefully that engineer is working closely with the architect involved in the project. Sometimes our members aren't always attending to those things as well as they might be. But ultimately, envelope issues are the responsibility of the architect. So yeah, which includes sealants and air barriers, vapor barriers, any sort of product that prevents the penetration of water.
So renovation is a big market in Western Canada now because of the age of the current stock of multifamily. They're coming up on their first window and exterior siding and cladding renovation timeline. And most building owners are not aware that if they're going to do a significant renovation regarding the windows, that they should be consulting an architect or involving an architect. And in fact, in the building code, unless you're changing the size of the opening, you don't even require a building permit for this work, is my understanding. So how do we fill that particular hole in what's going on out there right now?
Well, that's an awareness issue too, because there's other aspects of the building code and the Architects Act that basically states that if there's any sort of alteration, that triggers professional involvement. So there's times where that involvement is overlooked or sidestepped. But the legislation is pretty clear. Just because it's a renovation doesn't mean it's any less important than a new build project.
So that's pretty much it for the questions. We have someone asking if they can get the presentation, but just so I'm just going to use the occasion here. Everything we presented and that we will present this week too, most of it will be on our YouTube channel. So it's something that people can go back and watch again. And then, we like it better because it's in context too, like with you guys comment to it. So the official YouTube page is there for that. Is there anything else you guys wanted to mention that you didn't have the chance to mention at this point? Doesn't look like it.
I'd like to thank Dave for bringing this issue to a higher profile.
Mm-hmm.
Definitely, we really appreciate Randy Krebs getting involved in the AAA to consider this as well. I think this is a great opportunity to bring this message to a wider audience, really just to help everyone appreciate a gap in the code that kind of has led to some confusion, and that people should be aware of, just so that we can basically do our jobs better, and and essentially make sure that everyone's on the same page with respect to the expectations of what needs to be done. So we're very grateful for Randy's participation, and Peter, we appreciate you being involved as well. And so we hope that this will be a kind of a public service presentation that can be shared with other people to kind of help get the message across to a wider audience than we could reach otherwise through an event like this. And so we're, and in a way, this is part of what we feel is important that we can offer the industry as Fenestration Canada, is to provide educational events like this. So,
yeah, 100%. And that's why it's going to be online too, right after this presentation. It's in fact, it's live, and we have people watching on YouTube right now. So, we're already reaching wider than our own membership here. So that's pretty great.
Hit the like button, right?
Yeah. Well, while you're at it, hit the like button, hit the notification button, so you'll know whenever we go live with any sort of content. I just want to thank again Vecca for their sponsorship, being presenting sponsors for the regional week. We have full pack day tomorrow again. This time it's going to be with Ontario members. But as I said, you probably all got the links to attend, and I would encourage you to attend those seminars too, because a lot of stuff is getting talked about, and it's good to know what's happening in different provinces, and it's also most of the time relevant to everyone. So hope to see you tomorrow and for the rest of the week. Thanks again, everyone, and have a nice rest of our afternoon.
Yeah,
Thank you.
Thank you very much. That was great.
Thank you.
Thank you. Bye-bye.